Hello engineers, welcome to Engineer Brandon's Tools. So today we are on our second lesson of MATLAB. So our program for today is we are going to do exponential and logarithmic functions with MATLAB. We are going to do complex numbers with MATLAB. So if you watch my previous video, you understand the main basics of MATLAB. So I have some examples which I have set for this tutorial. Okay, here we are. So here, this is our program for logarithmic and exponential functions of today. So I have given 3 examples. By solving these 3 examples, you will be able to know the basics of exponential and logarithmic functions in MATLAB. That is, you know how to declare them and you know how to use them in calculations. So for the first example, we have been asked to calculate e raised to the power 2. So as a mathematician, you know that e means the natural number, which is approximately 2.71. So if we want to write this in MATLAB, we simply type in exponential, then we put in bracket 2. This simply means e raised to the power 2. Then if we hit our enter, we are going to see that our answer is 7.3891. So that is the exponential. For instance, let me say I want to find the exponential of -5. I'll just type in exp, then -5. So that is the exponential of -5. Then I notice that my answer value has been stored in the workspace. So if you watch the previous video, you understand that whatever variables you use here are stored in the workspace. So let us move to the second example. We have been asked to find the logarithm of 2 to the base e. So e is the exponential number. So we are looking for the logarithm of 2 to the base e. So to do that, in MATLAB, the logarithm to the base e is simply written as log. So to find the logarithm to the base e, I simply tap log, then I put my 2. So that is going to give the logarithm of 2 to the base e. So if I hit the enter button, it's going to give me the value 0.6931. So that is logarithm to the base e in MATLAB. Okay, what about finding the logarithm of 2 to the base 10? In MATLAB, finding the logarithm to the base 10, you type in log. Followed by that, you type in 10. Then you write the number. So in this case, I'm finding the logarithm of 2. So that is it. If I hit my enter button, it finds the logarithm of 2 to the base 10. So to prove this, knowing that logarithm of a number to the base of itself is 1, to prove this, I can simply type in log 10 to the base 10. It's simply going to give me 1. So that is the proof. Okay, let us move to the next one. We are finding the logarithm of 2 to the base 2. So to do this, I simply type in log. I type in 2, then 2. So that is it. Log 2 to the base 2 is 1. So those are the standard logarithm functions in MATLAB. For instance, if I want to find the logarithm to another base, let me say to the base 5, I don't think there is any function, there is no standard function in MATLAB that can find logarithm to the base 5. So to do that, I can perform change of base. That is, I'm looking for the logarithm of 4 to the base 5. I can change it to the base e to the base 10 or to the base 2. For instance, let me find the logarithm of 4 to the base 5. So let me clear my command window. So to find the logarithm of 4 to the base 5, I'll use change of base. In this case, I'll change it to the base 10. So I'll find logarithm of 4 to the base 10, which is written as this. Then I divide all that by the logarithm of 5 to the base 10. So this simply gives me the logarithm of 4 to the base 5. If I hit my enter button, we have as answer this. So this is simply the logarithm of 4 to the base 5. Okay, so let us move to the next example. So here we have example 3. We have been asked to find the square root of 9. So you notice that on our keyboard there is nothing like square root like on a normal calculator. In MATLAB there is an easy method of doing this. To find the square root of a number, you type in sqrt. So in this case I'm looking for the square root of 9. So sqrt of 9. So knowing that square root of 9 is 3, if I type in enter, it's going to give me as answer 3. So that is how square roots in MATLAB are being found. You can be able to do basic operations in MATLAB with logarithmic and exponential functions. So without wasting time, let us move to complex numbers. So I also have some questions concerning complex numbers here. So we have been asked to give the real and imaginary parts of complex numbers. So here I'm going to clear my command window, CLC. So declaring a complex number in MATLAB is not a difficult task. So here I have the complex number z equals 2 plus 4i. In MATLAB, it's basically the same idea, just that in MATLAB you have to put 4 times I. So here let me define the complex number z in MATLAB. I'm just going to say z equals 2 plus 4 times I. So that is my complex number z. So if I hit the enter button, I'm going to see z as 2.0000 plus 4.0000i. So that is basically the same thing. So we have been asked to find the real and imaginary parts of the complex numbers z and w. So I've defined my z. So to find the real part of a complex number, you simply type in real of that complex number. So real of z is going to give the real part of my z. So if I hit my enter button, I'm going to see that it's going to return a 2, which is the real part of this z, because z is 2 plus 4i. 2 is the real part, 4 is the imaginary part. So let me find the imaginary of z. So to do that, I simply type in imag of z. If I hit my enter, it's going to return 4 as the imaginary part of the complex number z. So that is it. So I give you the B part to solve as an assignment. So let us move to the next example. So we have been asked to find the angle of the complex number z, which is 2 plus 4i. So basically it is this our same z here. So I notice that z has been stored in the workspace as 2 plus 4i. So I'm going to leave it the way it is. I'm going to continue the calculations with it. So to find the angle of a complex number, I simply type in angle. So in this case, I'm looking for the angle of z, so I'll simply type in angle of z. So it's going to return me the angle, which is 1.1071, and this angle is in radians. This angle is not given in degrees. This angle is given in radians. So for instance, let us find the angle of W. So I can say angle of W. What is my W? W is 5 minus 2 times I. So if I hit my enter button, it's going to give me the angle of W. So that is it. So let me clear my command window. Please follow me step by step, not in order not to miss a step, please. Okay, so here we have been asked to find the complex conjugate of the complex number W, which is 5 minus 2i. So we have not yet stored our W in our workspace, so let us declare W as 5 minus 2 times I. So if we hit the enter, we notice that W has been stored in the workspace. So finding a complex conjugate of a complex number in MATLAB, you simply use the command conj. So to find a complex conjugate of W, I'll simply type in conj of W. So it's going to return the complex conjugate of W, which is 5 plus 2i. We notice that W is 5 minus 2i, so its complex conjugate is 5 plus 2i. So as assignment, you can find the complex conjugate of z using MATLAB. Then for the next exercise, we have been asked to find the magnitude or the absolute value of the complex numbers z and w. So to find the magnitude or absolute value of a complex number in MATLAB, we simply use the abs command. That is, to find the absolute value of z, I'll use abs of z. It's going to return the absolute value of z. So if I hit my enter, it's going to return the absolute value of z, which is 4.4721. So that is the absolute value of z. Okay, let us find the absolute value of w. So absolute value of w, abs w, if we hit the enter, it's going to return its absolute value, which is its magnitude. So thank you for watching my video. Please don't forget to like, comment, share and subscribe. And in the next video, we are going to do matrices with MATLAB. Thank you.